We're now going to talk about writing equations of quadratics on the calculator. Notes for some calculator buttons, you'll see this in a minute, but calculator buttons that you're going to want to press in order to do regression, stat, edit, and then you're going to type x values into L1 and y values into L2. Then you exit out. So you hit second and then mode to quit. Then you go back to stat. You're going to want to go to quadratic regression. The reason it's quadratic regression is we're doing parabola or quadratic regression. And then you hit enter a bunch of times, and then out will pop a quadratic equation of the form y equals ax squared plus bx plus c. And you'll see me do it in a minute. Okay, so question 1 contains the points 322, -6, -50, and -3, -32. Now, as we know, I'm going to write this down, but you don't have to. Last chapter, we would have solved this 3 by 3 by doing a system. So I substitute 3. I'll try and do all of these in a different color just to make it easier. So y equals, I'm sorry, I'll plug in 22 for y. So 22 equals a times 3 squared, so that's 9, plus b times 3 plus c. If I substitute in the second stuff, I get -50 equals -6 squared is 36 times a minus 6b plus c. And then my third equation would be -32 equals, I sub in -3 squared, I get a minus 3b plus c. And then I have this 3 by 3 system that I'd have a lot of fun solving. It's actually not too bad because all of these values here end up being pretty easy to eliminate. But what we're going to do is we're going to use quadratic regression. And something that's kind of important to note is that when you use regression, what ends up happening is just like in linear regression or in a line, if you have 2 points, you can draw a line. As you move up in power, you need to move up in number of points. So 2 points gives you a line, 3 points gives you a parabola. So if we have exactly 3 points, we can find the parabola. So let's go to stat edit, clear out, don't delete, clear out L1 and L2. And so now what we're going to do is we're just going to type these points in. So all of my x values are going to go into L1. So I have 3, -6, -3. And then the y values that correspond to those values are going to go in L2. So 22, -50. Make sure you put the negative sign, not the minus sign, when you're subbing in negative numbers. So I type those in, then second mode quits me out. And now I hit stat one more time, hit the right arrow to go to calculate, go to quadratic regression, which is option 5. Just like we learned when we were doing linear regression, we can type vars, yvars function, and it can store it for us in the y equals, but we're not really going to use that today. And then it tells me my answers. So 0.33333, that means 1/3. So 1/3 x squared plus 9x minus 8. Oh, that's sad. So 1/3 x squared I totally forgot what it was, plus 9x minus 8. I'll do the same thing for problem 3. So if I go to my calculator, I hit stat, edit. I'm going to clear out the answers that I have. And then I will type in 1, 3, -2 for my x's. And then the y values that correspond with those are 27, 19, and -6. So then I go, I want to quit out, stat, calculate, quadratic regression. Again, I could store it, but we're not really using that at the moment. I hit enter and I get my answer. So -3x squared plus 8x plus 22. -3x squared. Don't forget to put the y. So -3x squared plus 8x plus 22. Press pause in the video and try problems 2 through 4 just to make sure you know what you're doing on your own. Problem 2, the answer is y equals -2x squared plus 24x minus 64. And on problem 4, the answer is y equals 3/4 x squared minus 2x plus 10. Just make sure that you're able to do that. If not, ask questions in class. Finally, quadratic regression if we have more than 3 points. So regression is actually not intended to give you an exact parabola that goes through every point. Just like when we did linear regression that was trying to find a line that best fits the data, quadratic regression is actually designed to find a parabola that best fits the data. But oftentimes, in the problems that we were given, since we were only given 3 points, it actually exactly fits the data. But in this word problem, for example, there are 5 problems or 5 points. We don't know, it's not probably going to actually hit all of these points, but it's going to make a parabola that best fits these 5 points. So, Wing Stadium is testing the amount of profit they get depending on the price that they set tickets at. So here's what we got. $25 tickets gives you $15,000 in revenue or profit. $35 tickets increase your profit. But notice that when they have $75 tickets, not as many people are coming and they don't make as much profit. So this is kind of an important question for businesses. What do I set prices at in order to make the most profit? So what is the maximum profit Wing Stadium would expect and at what ticket price? And then how much profit would they expect if they had a ticket price of $70? So in order to do that, let's edit what we're doing. So I'm going to clear L1 and L2. And I'm going to substitute in all of these values. So my X values are ticket price. So 25, 35, 50, 60, and 75. And then L2 are going to be profit. And for simplicity, I'm just going to get rid of the 3 zeros and then put them back in at the end of the problem. So 15, 25, 75, 60, and 30. So that ends up being all of my profits, except I need to multiply the answer by 1,000 when I'm done. So I will calculate a quadratic regression for this. And then I'm definitely going to want to store this as my y1 so then I can mess around with it on the graph. So this ends up being my equation. My equation, and I don't really want to round it until the very end, but when I'm writing an equation down on paper, then I can probably round it to 3 decimal places. But that's why I'm storing it as my y1. So I have y equals -0.071 x squared plus 7.546x minus 136.833 minus 136.833. So let's analyze what's happening on the graph. So that's my equation. So let's go to my y1. I'm also probably going to want my stat plot on so then I can see where the points are. And I'll zoom stat. So here are my points. Notice that the parabola doesn't exactly hit all of these points. As a matter of fact, it doesn't hit any of them, but this is the best guess that we can get for profit. And it's clearly off at certain points. Like if I trace, I can see that when I have a $50 ticket, we actually made $75,000 at the stadium. The model is only predicting $63,746 profit. So the model is not going to be perfect. Okay. Now, in order to find the maximum value, the value of the vertex, I can hit second, trace, that gives me calculate, and then I have some options. I'm going to go to maximum. So I go to maximum. The reason I'm picking maximum is because there's actually a maximum. In order to get a maximum, I'm going to hit enter on the right side, or I'm sorry, the left side and the right side of my maximum. So as long as my spider is on the left side and the right side of my maximum, it will actually give me what the actual maximum value is. So the maximum value that we're predicting is going to happen at $53.37. If we have a ticket sale of, or a ticket price of $53.37, that's predicted to be my maximum amount of profit. And obviously, it's not completely accurate because we had more profit elsewhere. But the model is predicting that at $53.37, we make $64,550. So the profit is expected to be $64,550. That's not the most profit they ever got, and it's not exactly the same price, but that's kind of the prediction that we're getting based on this model. And again, models aren't perfect, and in real life, things happen. So, for example, the $50 ticket, there may have been some act that was really hot at the time for that concert, and so more people ended up showing up than you would think, and they maybe didn't price the tickets accurately in order to make the most money. How much profit would Wing Stadium expect if they had a ticket price of $70? So you can hit trace. You don't want to trace the data points, you want to trace the parabola. So at 70, you would expect $45,001. Or if you rounded, $45,002. And I know I just said round to 3 decimal places, but in this problem, it's actually like within context. I can't round to 3 decimal places because it's money. So I can't really do that.